In this session, we will be talking about coefficient of variation. In my previous video, I've explained to you what is variance and what is standard deviation with a solved example. This can be easily done manually. So how coefficient of variation, which is written as CV, is different from standard deviation? Both of them are measures of dispersion of data. The point here is that standard deviation can be found out for a single data set. It cannot be used to compare the relative variability existing in two different data sets. I will show you with a manually solved example how this is actually done. So we need coefficient of variation to compare two different data sets which may be measured on different measurement scales. Say you can do a comparison between the height data and the weight data, height measured in feet and weight measured in kilograms. You can compare both data sets using coefficient of variation. Now, how is this useful? This is useful to see the stability of the data, the consistency in the data. That means the lower the coefficient of variation, the higher the stability of the data. So what do I mean by this? Let us explore it through an example. CV is a dimensionless standardized measure of dispersion, also known as relative variability. Standard deviation is known as absolute variability. This is relative variability because it compares the spread of data between two or more data sets which possess different means. So the assumption over here is they should have different means regardless of their measurement units and is expressed in proportion to the sample mean. So the value of CV is expressed in proportion to the sample mean. That's why in this formula you see it is computed as standard deviation divided by mean, and then we multiply it by 100 to give it a better view of assessment by converting it into percentage. It is suitable for ratio scale data, which has an absolute zero, indicating the absence of quantity. So absolute zero means that the data has to be in ratio scale. When you talk about interval scale, it does not have an absolute zero. Say the measurement of temperature in centigrades or Fahrenheit. So in that case, 0 degree centigrade does not mean that it does not have any value or any sense belonging to it. It does have a sense belonging to it. But when we talk about ratio scale data, the example over here is height or weight. So if we say 0, that means there is no height. If we say 0, there is no weight. That is why it is known as absolute zero. In interval scale, we have arbitrary zero, false zero. Now, lower CV indicates lower variability and higher stability. So we want to have a lower CV to indicate a higher stability in the data sets and assess it accordingly. Now here is a beautiful example I have framed in for you to understand it in a better manner. A researcher wants to compare the consistency of domestic and foreign tourists' arrivals at a popular beach destination. Why? To help in future budget planning and marketing strategies. He wants to see the consistency of domestic and foreign tourist arrivals in a destination so that the future budget planning and marketing strategies are directed towards that particular group of tourists, whether it is domestic or foreign. So it will be directed towards that group of tourists. He has the summer season, that is 3 months from April to June, April, May, and June, population data from the destination. That means he has the entire data of tourist arrivals. So in this table, you see domestic tourist arrivals in April 56,000, foreign were 45,000, May 64,000, foreign were 50,000. In June, domestic tourists were 54,000 and foreign were 43,000. Now, if you see it closely and I ask you that which group of tourists, whether it's domestic or foreign, display a consistency in their arrivals. So it is hard to judge, it is hard to find by looking at these figures that which group is more consistent in terms of arrivals, right? For that purpose, we use coefficient of variation to compare both of these two groups and find out which one is more consistent, right? In this case, first we need to find out the mean. So we just add up these three values and divide it by 3 to get 58,000. For foreign as well, we add up these three, 45,000, 50,000 and 43,000, divide by 3 because there are 3 months to arrive at the mean, that is 46,000. And then we need to find out the standard deviation. The formula used for this case is the population standard deviation because we have the complete population's data. It is not a simple data. In case it was a sample data, then we need to do n minus 1, which is the sample size minus 1, which is according to degrees of freedom. You have one lesser degrees of freedom in a sample selection, which I have explained to you in my previous video. You might like to go back and check the video on variance and standard deviation to know about the reason why we have n minus 1 in the denominator for sample calculation if we are calculating variance and standard deviation for the sample. Now, using this formula and entering all the details, this one is the score and this one is the population mean. The observation or the score, arrivals in this case, minus the population mean, this is known as deviation. We square the deviation, we add up it all for all the observations, say for domestic 56,000 minus 58,000 and then squaring it up. 64,000 minus 58,000, which is the mean for domestic, right? And then squaring it up. So we do it for all three observations, add it up because it's a summation, then divide it by n, which is 3. 3 months are there, right? And then we find the square root of this thing to arrive at the standard deviation. So the standard deviation for domestic is 4320.49. Standard deviation for foreign tourist is 2943.92. Now, after getting the mean and standard deviation, we need to use this formula and just plug in these values into this formula for coefficient of variation. Standard deviation for the domestic 4320.49, mean for the domestic 58,000, and then multiply by 100 to get a value in percentage, you get 7.44%. Similarly, doing it for foreign tourists, you get 6.39%. Now, since the result shows that the CV is less for foreign tourists, so there is less variability and more stability in their arrivals as compared to domestic tourists. So we got our result, and the researcher would now like to frame in the budget and marketing strategies directed towards foreign tourists which display a higher consistency in their arrivals as compared to domestic tourists. So this was all about coefficient of variation, and I hope you have learned a lot. You got a lot of information and you will definitely share it with your friends and faculty colleagues. Keep supporting the channel, keep viewing it, and you might like to connect with me on my Gmail address. You can do so. Thanks a lot.